Good morning, welcome back. As you can hear, it's absolutely lashing it down with rain. It's an absolutely awful day out there. We've got the silage trailer in well before schedule to put a new rear door on it, so we're falling back on that in between jobs. As yet, we're unsure whether we're painting this silage trailer as well, so stay tuned for that and we'll get another video on that one as and when we get the go-ahead to do what we're going to do. Today, we've got some digger buckets that need modifying. They're currently out on the yard, so I'm just waiting for the rain to stop a little bit so we can not get a bath when we go out to fetch them. So we'll bring them in to here, and what we've got to do is the gentleman that's bought them, he's bought them with an auction, and when he got them home he didn't realise that the pins on these are slightly bigger than the pins on his digger. So we're going to have to take them out, machine them down and put them back in again. So stay tuned and we'll get that done. So these are the buckets in question. This is a genuine JCB bucket that came off the machine. This fits, this is on 40mm pins. This one is one that's come out the sale on 45s. Potentially could be a genuine JCB one again, although it's not marked as JCB. And here we've got a Rhinox bucket. So what I'm going to do now is I'm just going to go with a grinder and just touch down on every pin at the outer extremities, so I can see what see where they lie in the ears on the bucket, and then that'll give us a mark of reference to when we get onto the lathe. So as you can see, I've just chucked this up in the lathe. I haven't been too fussy about this because for the application it's used for, we don't need to worry about the down to the minimum thou here and there. So what I've done is I've just touched up with the tool on the far end here and turned the chuck until it's concentric by eye all the way around. And for this job, that'll be close enough. So now I'm going to pop a centre drill in the end, not with this drill obviously, with a centre drill, and then we'll machine between the marks that we've already created on here with the grinder. So there's one there and one there. So for those of you that don't know what a centre drill is or haven't seen them before, this is what a centre drill is. It's a short, stubby little drill bit with a chamfer already built in. And basically, you only ever use the first proportion of the drill because they have a tendency to snap off if you don't. But they're highly rigid in the chuck and they don't wander. So that's a nice little tool to keep in your toolbox, well worth having. So now we're wanting to do the drilling operation. What's really nice about this lathe, even though it's a Chinese lathe, it's got a hand jog on it, so you can just use the hand jog to get in between gears to change. Just allows the gearbox to revolve a little bit. So now that's in position on the slowest setting possible. We're on 70 RPM, and we can check that with the hand jog before we actually fire the machine up. So fire the machine up now, put a centre drill in the end, and then we'll start machining between centres. So there we are, we're now drilled into the end of the shaft. Something to note when drilling is I like to use a bit of a thread cutting compound or cutting oil. These are the ones I use. This one I really like. I find this one absolutely brilliant, the Tough Cut. That's a nice cut in lube. I'm also finding the Timco one very similar in a spray format. I would potentially say, I shouldn't say it, but I won't be surprised if these two are made in the same factory and just chucked in different cans. This stuff, the aerospace paste one by HMT, the lube version is brilliant, but very expensive, and I don't personally see it any better than the Timco or the Tough Cut. The Aero Paste one, well, in my opinion, is absolute rubbish. You might as well spray it with silver paint. It's crap. But yeah, those three are the ones I like. The only time I would use that is if I was... I don't even see it works, mind, but the only time I actually would use that is if I was drilling upside down overhead. I didn't want it to drip in my eyes or something. It does stick to the workpiece, but I don't personally find it helps a huge amount. So yeah, we'll get back to this now, and I'm going to start turning between centres. So there we are. It's now machining. I'm turning it on the second gear then. It's 115 RPM. Don't want to turn it overly fast because we don't want to be making this bar itself chatter too much. Like I say, it's not overly critical because the jaws on the hitch are hydraulically opened, so they'll lock up solid on it regardless. But let's try and get it as close as we possibly can without breaking the bank. And yeah, we'll machine that across now, and then we'll take it second pass across it. We've got a little bit there that hasn't cleaned up, but when I checked it with by eye going round, we have got a point that's been on the old quick hitch, and that's where it's been rubbing mainly, so we can machine that out now. So far I'm quite happy that this is machining relatively tidily. I was a little bit concerned at first because some of these pins can be case hardened and they're absolutely rock solid across the face for the first bit, and what I found is the best way to do it then is to actually grind the first bit with a normal handheld grinder, and then put it in the lathe and machine them, because some of that case hardening that they put on, especially on the older machines, seems to be rock solid, and it just damages tips. High-speed steel seems to be slightly more forgiving because the tungsten carbide ones are a little bit brittle, but this one seems to be machining as well as can be expected, so that's good. Probably another 4 passes on this to get this down to size. It'll take 0.5 mil each time, and that'll be that done. So yeah, little backstory on this lathe. This lathe actually came from my old school, my high school. I remember them buying it. They bought it when I was probably 2 years from finishing school, and I left school at 16. I'm now 32, so that gives you an age, gives you an idea of the age of the machine. Yeah, so it was bought. It was given to the engineering students, and before I had a chance to actually run it, they supposedly had broken it, and it was a gearbox fault. They couldn't seem to find parts, or didn't want to find parts. I'm not sure what the entirety of the story was. They sheeted it over and it was left, and some 6 years later I caught wind that it was going to scrap, and I managed to save it from the scrap pile and purchase it. I then bought it back here, and it sat in the corner of a shed for another couple of years before I had a chance to actually look at it. Turned out it was one gear had meshed with another gear internally, because somebody had pulled a series of levers in the wrong order. Hadn't actually caused any damage to the gear, but it had bent the shaft that it was on. So I managed to strip the gearbox down to that point, pull the gear shaft out. I would have called it a lathe shaft, but there's no real lathe shaft in the gearbox, lathe gearbox as such, because you've got, on this one, you've got 3 shafts internally. Managed to pull that gear off, straightened the shaft as best as I could in a press, kept putting a DTI across it, or digital indicator across it, till I found that I was just true as possible, put it back in, and to be fair, it's run faultlessly ever since. However, as you noticed earlier on in the video, we did have a slight grinding between 70 and 115 RPM, and that's the only one that we do have a little bit of problem with. But using the hand jog and by nursing it in quietly, it seems to do majority of everything we need. I'm not a machinist, and I don't profess to be a machinist. I run a welding company primarily, and it just happens that we own a lathe, and this is what we do primarily with it, is pins, bushes for diggers, making the odd bush for the tractor linkage or something like that. It's precision engineering on the very low end of precision. So yeah, that's what we're currently doing. We've also bought a milling machine, a large mill, for doing the line, to go alongside our line boring setup for the smaller diggers. We find that line boring is becoming more and more popular. However, we get a heck of a lot of people asking, can we line bore 1.5 ton, 2 ton diggers? We can, yes, but the setup time and the cost of it usually turns customers away. That's not to say we haven't done them. We have done a few now. However, with the new milling machine, we're hoping that we can lower the costs and make this more readily available for more and more customers. So that's the hope. As yet, we haven't set it up because I haven't had time to actually get round to setting it up. Hopefully we'll get that done over Christmas, but between Christmas and New Year, in my head, always seems to be about 13 weeks, and I get all these plans to do and then get disappointed when it's the New Year and I haven't done half of them. So we shall see whether that gets done or not, but it is up relatively high up on the priority list. However, I'm probably going to set the iron worker up before we set the mill up. So just a little note going back to the case hardening. What you've got to be careful of is when you machine case hardened pins, is the actual parent metal under the case hardening is usually very soft, and that isn't quite what you want for a digger pin. So it's best off, if they are case hardened and you're not pushed for time, to actually scrap that pin, purchase another piece and machine the pin up again out of something like EN8 or EN16. Usually for digger pins we use EN8, and for the bushes we use EN16. That's the way we normally go. Just primarily for the cost factor. However, if you want EN16 pins, we'll make you EN16 pins. We always do the digger pins themselves, like knuckle pins, the king post, everything like that. That's always EN16. But digger buckets, I usually class them as a wearing part, and EN8 is perfectly suitable for the lifetime of the bucket. On a side note, this lathe, the lathe I learnt on, first of all, was a Holbrook lathe, much older machine, and it was in SRM engineering. That's what I learnt on, and the dial on that, from memory, well, I know it's definite. If you turned it 5 thou, it was the cutter itself moved in 5 thou, and therefore, as the part revolves, it's actually taking 5 thou off this side and 5 thou off this side. So it actually becomes 10 thou. On a side note as well, I don't often use this lathe. Well, I say don't often use this lathe. I use it probably, seems to come in drips and drabs. I could be on the lathe like this week. I've been on it quite a few times, and I'll use it for 5 or 6 days consecutively for like an hour a day, and then it might be that 4 months will go by and I don't use it at all. So the constant battle, especially in what is only a farm shed basically, is condensation. So especially this time of year. So what I've found it works best is a mixture of WD-40 and a little bit of gear oil, and that seems to stay on there well without going overly sticky and stuff sticking to it. And then what I do then is, if I've got a big job on, I should have done it for this to be fair, but I haven't, is I get a bit of thinners in another squeegee bottle, chuck some thinners over it, wipe the oil off with a rag that's got any dirt stuck to it, put a little bit of fresh 3-in-1 oil, use the lathe, and then I use the same gear oil, WD-40 mix to chuck back over it again afterwards. We did have a sheet on this, and I found that sometimes of the year that worked really well, kept the dirt off, but what I also found in other times of the year, it used to sweat on the underneath of the sheet, and that used to drip condensation on. And for some reason, I don't know why, I find that condensation water seems to be more corrosive and aggressive to the material than damp, wet air. If you leave a machine out and it gets a bit of rain on it and you wipe it off quick, because you've just come home and you've just bought a machine and it's on the back of the trailer or something, you get caught in a shower, it doesn't seem to cause much damage. But you have condensation on it for a couple of days, and that really seems to leave surface rust. So my personal opinion is oil them up, wipe them off afterwards. Try and keep the machine as best as you possibly can. Like I say, in the ideal world, we'd all have temperature controlled workshops at 25 degrees, underfloor heating, and it'd be lovely. And jokes aside, I actually know somebody that runs a workshop like that, and it's absolutely blooming marvellous. But I wouldn't like to pay his electricity bill. So yeah, that's what I do in the farm workshop. I chuck a bit of oil on it. A little side note to discuss whilst this is machining is, would I buy one of these again? Yes, for the price I paid for this one, most definitely, because basically I saved it from the scrap, and I just doubled the scrap price and gave them a bit of a drink on it. Would I buy another one? Off the shelf, these are now coming in at about 8-9 grand. Would I want to pay 8-9 grand for it? Probably not. So there we are. That's those two pins in, and we've also done one outside the same. So we'll go and have a look at that as well. So they're ready to go back to the customer.